Then we're going to talk about some of the common types of roofs and panels that.
Michelle, I made a mistake. I forgot to start the broadcast and everybody was in hold. So if we can start over again, I apologize for that to everybody. My name is Paul Deffenbaugh, and I am the editorial director for Metal Architecture magazine and the one who has kind of messed up the start of this webinar. Today, we're going to do strategies for success with aluminum zinc coated roofs, and it's presented by Steelscape, and it's part of our webinar series. Michelle Vondern, who some of you may have just heard start because I forgot to start the broadcast, is our presenter today, and I'm going to turn things over to her in a moment. And a couple of things. If you want to ask questions, we'll take questions at the end of each section. There are 3 sections, and so that's end of each section, and then at the end of the webinar, I encourage you to submit your questions early. And for those of you who want AIA credits or certificates, all of that's going to be handled automatically. Please allow us 5 business days for everything to process. Tomorrow, you're going to receive an email 24 hours after the end of this webinar with links to more information. It's going to include a way to download the deck, a link to ask technical questions, as well as a link to review this webinar again. But let me turn things over to Michelle now, and Michelle's heard me do this introduction already, but the audience hasn't heard it. Michelle's the technical manager for NS BlueScope Coated Products in North America. She graduated from California Polytechnic State University in San Luis Obispo with a Bachelor of Science degree in chemistry. And she started her career as a research chemist with Morton, which was later BASF Coil Coatings, with a focus on polymers. This position also included lab development as well as lab to production scale-up and manufacturing quality and process control. Eventually, Michelle shifted her focus to cool pigmentation, where she brought the first cool coil coatings to market. And she's been active in the Cool Roof Rating Council and Energy Star Roofing Program. Michelle joined Steelscape as quality engineer for the Rancho Cucamonga, California paint line. And while there, she's held the quality systems manager role and is now the technical manager. She oversees quality systems and technical service for BlueScope Coated Products North America, which comprises Steelscope and ASC profiles. Michelle, an active member of the National Coil Coaters Association, and she sits on the technical committee, as well as the Zinc Aluminum Coaters Association. And since we're talking about aluminum zinc metal roofing, that is appropriate. Michelle, I'm sorry I messed us up at the start, but please take us away again.
Okay, no worries, Paul. I got to listen to Paul, sing my praises twice, so not a bad thing. Welcome, everyone. We'll jump in. I think you heard my first spiel about not doing any chemistry quizzes or questions today. It's my promise to you. And these are the sections that we're going to have today: understanding what aluminum zinc metallic steel coating is. We're going to identify some of the most common roof types or panel types that we see out in the market. Talk a little bit about how to design for optimum performance and longevity of this product. And then we'll talk about some installation and maintenance elements that go along with this for longevity and to get the best out of the product. So what is an aluminum zinc metallic coated steel roof? It's a mouthful. It's commonly known by the trade names of either Galvalume or Zincalume in the market. This reflects a base steel which is coated with a specially developed metallic coating, aluminum and zinc, in a very specific ratio that provides superior corrosion resistance. These products come in many forms, shapes. They can be bare or painted, painted probably being the predominant item that we see. Can be formed into a vast array of panels, shapes, stamped pieces, roll formed pieces. So we're going to cover all of that today. What is the purpose of a metallic coating? To start with, it's to provide corrosion resistance and to protect the base carbon steel. I think all of us know that steel rusts readily. Can't really leave it out in the elements, so we got to put something on it to protect it. So usually it's either a layer of zinc, straight zinc, that would be your galvanized products that most people are familiar with, or it's an aluminum zinc mixture applied to the steel to get that corrosion resistance. Corrosion is an electrochemical process, causes the steel to, oxidize, become thinner and weaker, so we want to avoid that. This metallic coating is put down prior to any painting or any additional coatings that go on. It's an active coating. And it's providing really two types of protection. You're getting a barrier protection and also a galvanic or a sacrificial protection because of the zinc and aluminum both being on there. It slows the rate of corrosion dramatically, but does not stop it completely. So you will have some corrosion over time, but very little compared to other products. Here we have kind of a diagram of a cross section of what one of these coated panels would look like. You got your base steel, which is actually the bulk of the thickness, your base metal. The yellow here would be your very thin layer of metallic coating that would go on. And then if it's a painted product, you'd have some pre-treatment, primer, and then a top coat and a backer. But let's go back to the beginning. So what is, how do we get this coated, metallic coated product? It's in coil form usually. So imagine giant rolls of, I like to say giant rolls of toilet paper, but made out of steel. That's what we're working with. So base steel comes in giant rolls. Probably in the 50 to 60,000 pound range is how big we're talking here. Gets cold reduced and trimmed to the width and thickness that it needs to be for the final application. Then we put a metallic coating on it. While we put the metallic coating on, we're also changing and altering the mechanical properties, the structural properties of that steel. We'll talk about that a little bit more. Then after that process, if it needs to get painted, it would move on to a continuous paint line to get its paint put on. And then it's transported out to roll formers or fabricators, where this would be rolled out into sheets or roll formed or stamped into panels to be used in construction. This is a simplified schematic of a metallic coating line that mills like Steelscape have. It runs continuously, so you have two coils loaded at a time and you weld the ends together so the line doesn't ever stop. Starting from the left, moving right, it would go through an accumulator tower. These towers or threaders allow us to take up slack or let slack out in the line so that we can run without stopping. We'd go through a cleaning section. You got to get that raw steel clean, get all the oxidation and rust and stuff off the surface. Then it would go through an annealing furnace, direct fire furnace. Normally, you're actually heating the strip up with flame. This is, again, cleaning the strip so that you can put your metallic coating on it. It's also now annealing the steel, so you can get whatever grade of steel you need, whether tensile strength, yield strength you need for the final product. That occurs in that section. Comes through a snout into a giant bath of molten metal, about 1100 degrees Fahrenheit, very high temperatures. Strip moves through that bath, metallic coating gets applied, goes through a set of air knives. These air knives are, spraying air onto the strip to control how much of that coating stays on the strip. We measure that by thickness and by weight. Goes through a cooling tower to get cooled down. You got to cool it at a very specified rate or that coating doesn't stick. Then it would go through a skin pass mill and some tension leveling. That gets a nice smooth surface, takes any shape out, so you have a very flat product at the end. And then you can apply some chemical treatments and passive it to help prevent rust, and maybe a thin resin coating. If it's going to be a bare product, we put a thin resin coating on it to prevent fingerprinting and to aid with forming downstream. And then out the exit end of the line. So these lines are run about 150 feet per minute and faster, up to 700-800 feet a minute these days on the newer lines, and they hold on average anywhere from 2,500 to 5,000 linear feet of steel from end to end. It's a very large operation, lots of material at once being processed. This is a little bit closer up of the kind of the meat of the line, I like to call it. This is where the action is happening. So you've got the direct fire furnace, the flame in there. And this is anywhere from 1,000 to sort of 1,500 degrees that you're heating the strip up to. Goes through these radiant tubes and these hot bridles to get further annealed, get your structural properties that you need. And then through the bath, there's a roll that sits down in this molten pot of metal that the strip runs along. Comes up, got your air knives there that's controlling your coating weight, and then off to the exit into the line. Some pictures of what some of that looks like. Starting on the left here, this would be cold roll full hard that hasn't had its metallic coating put on yet, that's being staged into the entry of the line. The second picture here is what the accumulator towers look like. In our facilities, these are about 8 to 9 stories high. Sometimes they're horizontal, sometimes they're recessed into the ground, depending on the mill that you're at. The third picture here is the pot. So the pot's down at the bottom here, and this shiny reflective surface that you see moving between these bars is the metallic coating when it's first applied before it's cooled down. And the air knives are this unit that sits right here in the middle. And then out to final inspection. A lot of quality control that goes on, both looking at steel properties, but also the weight and quality of that metallic coating that we've put on there. So metallic coated, I mentioned galvanized earlier. Galvanized and this Galvalume or aluminum zinc product are really the two most common coated steel products in the construction industry. Galvanized is 100% zinc coating, where the other product is a mix, 55% aluminum, 43% zinc, a little bit of silicone in there as well. This is an atomic level picture of those two products on a cross section. On the left is galvanized. So you can see it's 100% zinc. It's all very solid gray. These little crystalline structures are the interface between the iron, the base steel, and that coating that helps it attach, bonds together. On the right here is the aluminum zinc. So the, this gray area here is the aluminum. The white areas, I always think it looks like brain matter. The white areas are zinc areas. So you can see by volume, it's a lot more aluminum than zinc, which is why it has superior corrosion protection, is because of all of that aluminum that's in there. So again, it's 55% by weight aluminum, 43.5% zinc, and then 1.5% silicone. The silicone is in there for reactive purposes and wetting out purposes in that molten bath that it goes through, not really doing anything in the final product. But zinc is going to give you a sacrificial or galvanic protection, right? It's going to sacrifice itself to protect the steel underneath, while aluminum forms kind of a protective barrier oxide, right? Passivation that becomes very inert and doesn't really corrode much further after that initial oxidation level forms. So when we talked earlier about sacrificial and protective barrier, that's where it's coming from, the zinc and the aluminum. So what happens is these zinc areas in that structure are going to corrode preferentially, leaving the aluminum rich areas in that structure. And as you saw in that last picture, there's a lot of that aluminum left. So now you still have a good bond of the aluminum to the steel, and then the aluminum to whatever coating or paint you've put over the top, even though the zinc areas are gone over time. It's the same as process at the end of the day. It's hot dip galvanized material. The lines look identical. They process almost exactly the same. The difference is the pot mix, right? Instead of being all zinc, you have this aluminum zinc mix. And actually, a lot of steel mills run what we call a dual pot. They'll actually have a pot of both, and they can move the strip between the two. Not uncommon to see that. So the history of this product, I actually didn't realize, so I was reviewing my notes, that this product had its 50th birthday this month. It was first developed by Bethlehem Steel, was sold first as the Galvalume trade name in June of 1972, so sort of a milestone year this year for it. Bethlehem decided that after many years of developing this product, it took years and years and years to get it to market, and it almost didn't happen. There's a legendary story that goes around in the industry about some of the researchers that came up with this material forcing their way in the limo with the president of Bethlehem Steel at the time to save the project, because they were going to put the kibosh on it because it wasn't moving forward, and convince them otherwise. And now we have this fabulous product that is a mainstay in the construction industry. But they decided, instead of getting patents and holding it as proprietary, that they would license other steel companies to make it. So this is a licensed technology now. You must have a license to call it Galvalume, to use that trade name. Otherwise, it's called aluminum zinc, a generic name. Facilities that are licensed go under regular review, very high quality standards that have to be met. Product must be processed in a very specific way to carry that license and use the name. It's available in 28 plus countries now. It is global. I think there are 6 or 7 producers in the United States currently that have a license and make this product. So now we have well over 30 years, right? We've got the initial roofs now are 50 years old that went out into the market. We've been monitoring some of those for a very long time. And there's some pictures there on the right. This is a galvanized plus zinc aluminum roof in an acid rain environment. And what we're finding is that the Galvalume product outlasts galvanized by up to 9 times, and actually is outlasting the other building components used with it, right? So any galvanized components or components of other materials that are on a roof or a wall with the Galvalume product are failing first. So very long, great longevity. And we've got about, this is a little outdated now, it's probably more than this, but about over 30 billion square feet of material out in the market. So why this product, right? Specifically, why would we want to use it instead of galvanized? Well, it's the corrosion performance. So again, 9 times better performance in most environments versus galvanized, and it comes with a corrosion warranty. Most producers are offering a 20 to 25.5-year warranty against corrosion on this product. That is not something you're going to get on any other steel product in the market. There's some efficiencies in purchasing. Because of the density of aluminum versus zinc, you get more linear footage for the same weight on this product. So there's a little bit of an advantage there. It's readily formable into just about anything you want to form it into for wall or roof panels. And aesthetically, it's a very pleasing product, even bare. It has a very nice silver, very consistent appearance, very small spangle. It looks good left unpainted, but can be easily painted as well, which just adds to its protection too. Get an even better product. So this is just this is years to 5% red rust, kind of an industry standard, in different like rural versus industrial, moderate marine, and severe marine. And you can see that even in a severe marine, so this would be like constant saltwater spray. It still is going to be 15 years before you get any kind of noticeable and appreciable red rust on this product versus galvanized, and 30 plus in less severe areas. So I've tried to put some little graphics here to explain the difference between a galvanized product and this aluminum zinc product, and why the one is better than the other. So forgive my attempts here at artistic ability. On the left is we're trying to demonstrate what happens if you have a painted coated steel product and you get a scratch in the painted surface, right, down to that metallic coating. So now you have exposed zinc. Well, zinc is just going to continue to sacrifice itself until it's gone, at which point you're going to get down to base steel, and then you're going to develop red rust that bleeds through. And there's also going to be nothing for the paint to continue to adhere to. So you start to get paint uplift, and then it just kind of accelerates that cycle of corrosion at that point. Whereas on the right with the aluminum zinc product, so imagine you have the lattice, right, of our yellow, which is the zinc, and the purple, which is the aluminum. So the zinc sacrifices itself and goes away, but you still have this aluminum structure, crystalline structure there that prevents you getting down to the base steel and that red rust, and still gives something for the paint to adhere to. So you're less likely to get paint peeling back from scratches because it still is adhered to the aluminum. And again, it's about, on average, the rate of corrosion is about 4 times slower than galvanized. What we see out in the field is that the first couple years, the aluminum zinc product actually corrodes a little bit more than galvanized, but then like in years like 3 to 7, there's an inverse relationship that happens. Galvanized continues to corrode exponentially, and the aluminum zinc product kind of stops corroding. Same thing on the edge. Again, my attempts at some artwork here. So same thing on the edge. So you have a cut edge, a little bit of exposure there. On a galvanized product, that zinc is going to start to sacrifice itself and go away. Eventually, there's nothing here. Now you've got a flap of paint here. It kind of blows in the breeze and can peel up. And then eventually you get down to red rust, and you'll get red rust creepage up the panel, right, as that continues to deteriorate. But on the edge of the aluminum zinc or the Galvalume panel, you're left with the aluminum framework there at the edge that greatly retards that edge creep that we see. Here's some pictures. I think these pictures are better than my graphics. So on the right there is an aluminum zinc panel painted and a galvanized panel painted with the exact same paint systems, exposed in the exact same outdoor setting on a test fence. And you can see the difference there. after a few years, the galvanized is showing some red rust creep. And yeah, you have a little corrosion on the aluminum zinc panel as well on those edges, but not nearly as severe and as dominant as the galvanized. And again, this graph kind of shows that plateauing that we see of corrosion on the aluminum zinc product. Right, first few years, yeah, there's some corrosion happening, and then it just levels out. There are some ASTM standards that control this product that everyone's producing to. That would be A792. You'll see that in the specs, called out in architectural specs for 55% aluminum product. There's different coating weights, right? So we can put different amounts of this aluminum zinc on the strip. AZ55, AZ50 are going to be the most common for the building components world. We do see some AZ35 now, but usually for rainwater goods or interior products like appliances, we'll go down to that lower coating because they don't have the exposure to the elements. These weights are in ounces per square foot. So AZ55 is 55 ounces per square foot. AZ50 is going to be 50 ounces per square foot, which equates to about a 0.0018 of an inch total, both sides. So each side is coated with the same amount. For the AZ55, AZ50 is 0.0016 inches of product, so very, very thin layer at the end of the day, not much going on there. And again, we do recommend AZ50 or AZ55 for roofs and wall, and that's what's going to carry a warranty. AZ35 is not warranted for corrosion protection. So why AZ50 or higher, right? What happens when you get to the lower coating weight? So again, we have a microscopic atomic level cross-section photo here. On the top is AZ35, so much thinner coating, AZ50 thicker on the bottom. So these darker areas on here are the zinc areas. The lighter in this picture is the aluminum because of the contrast they used. You can see that when you're at a low coating weight, some of these zinc areas work their way all the way down to the base steel. Whereas on the thicker coatings, you have less of that happening. So on these thinner coatings, like we just talked about, the zinc sacrifices itself. It's going to go first. So what happens on these lower coating weights that have the zinc areas that go all the way to the base steel, once they've exhausted themselves and are done, you now have an open pathway to the base steel through the aluminum. But on the higher coating weights, you're much less likely to have that because there's so much more aluminum left at the surface. So what else? What else is great about this product? It's got a lot of performance attributes that I could do a lot of different webinars on. It has a very high SRI, solar reflective index value, about 67 to 69% and up. So really good for solar reflection. Readily paintable, right, with any kind of standard coil coating, including the cool colors. And most metal roof manufacturers are selling a line of painted product. Temp ranges are pretty good. It can withstand 600 Fahrenheit before you start to get discoloration, up to 1250 Fahrenheit without any kind of severe oxidation or degradation structurally, which is important if you're doing any kind of industrial application or a building that's going to have like high temperature venting or exhausting coming out of it. I want to make sure that the product can hold up to it. It's also readily field painting. If you didn't want to buy a pre-painted product or you needed to paint something after the fact, after it's installed, properly prepared product, readily easy to clean and can be powder coated or field painted with liquid applied coatings once out in the market. It's also weldable. Not that we recommended that for painted products, but the bare product can be welded. And of course, we've got, you guys probably know more about this lead stuff than I do, but right, lead, a lot of options to get some lead credits with this product. Certainly the heat island reduction part with the high SRI values, especially with painted product. And then the material ingredient reporting. You can get some on the bare product or the resin coated product, you can get some points there. Same with Living Building Challenge. Clear resin coated aluminum zinc product will qualify in most cases as red list free and can get that label. We're having a little bit of a challenge on painted product because the paint vendors don't want to release their proprietary ingredients and formulas, but we're trying to work through that as an industry and get more transparency on the painted product. There are a couple caveats to this product. There are some not so suitable applications for it. It's great for residential. It's actually pretty good in coastal applications. We'll talk a little bit more about that later. Severe weather, it does well. Industrial and commercial, it's fine. You can curve and taper this material. It's really good for retrofit applications. However, it does not like high alkaline environments, especially wet cement is problematic. You got to make sure that there's not a lot of direct contact with cement and even finished concrete because of the moisture retention. Animal confinement does not do well in animal confinement. We always recommend galvanized for animal applications. Slopes below 1/4 and 12, but that applies to all coated metal product, not just the aluminum zinc product, because you'll get pooling water, which leads to corrosion. Got to be careful about dissimilar metals in a corrosive environment. We're going to talk a little bit more in detail here shortly on that. And then in soil, culverts, buried building edges, like signposts. The aluminum zinc product is not well suited for that. We do recommend galvanized for those kind of applications. Okay, that's the end of the first section. So I will pause and see if there's any questions.
Thanks, Michelle. We got a couple of questions. I did want to mention though, since you brought up that the Galvalume is 50 years old now, that the inventor of it, Angelo Borzillo, was recently selected for the Metal Construction Hall of Fame. Andrew's still alive, and if people are interested, they can go over to the Metal Construction News website and read more about him. Interesting story, as you said. First question. You pointed out that one of your slides showed a series of roofs, one showing a Galvalume roof that is 30 years old, and this person's asking what the thickness of that roof was installed, and maybe that's part of a larger question. Does the gauge of the steel matter in the performance of the Galvalume coating?
Not really, very little influence. It's really the metallic coating. Those initial roofs that went out in the 70s were most likely AZ55 coating weight. That was the standard to begin with. And then as they got more data, they realized that you could go down to AZ50 and get very good performance as well. But the gauge, the base metal thickness underneath, really doesn't have much to do with the corrosion protection long term. Not much of a factor. It will influence formability, right, and your ability to get certain profiles, but nothing with the corrosion.
Thank you. And then another question, does factory paint coating on top of the aluminum zinc add significant life expectancy over just the aluminum zinc, factory aluminum zinc coating directly opposed when it's exposed?
Yeah, it can. I would say that where the paint really adds longevity would be any kind of non-standard environment. Coastal applications, right? Going with a marine rated paint system on top of this product in a marine environment, yes, is going to get you much better performance and probably a better warranty. In benign, normal environments, the paint really doesn't add much to the corrosion protection long term. Industrial applications would be the other one where your paint system, yes, will play a part in a role in the lifespan of that product.
And one final quick question, I think, once the zinc has been sacrificed, does the aluminum degrade in any way?
It does, right? But very, very slowly. It becomes quite inert. You get that aluminum oxide that forms on there. And yeah, you get a little bit of degradation, but that's why you see that flattening of the corrosion curve, is it becomes very, very slow. Yeah, and tedious. That's why we see very little change, you know, between 10 years and 20 years. But yeah, it's happening, but just at a very reduced rate.
Thanks. There are more questions here, but let's keep going and we can answer these towards the end. Thank you.
Okay, sounds good. Next section. So we're going to talk about some of the most common roof types, their advantages and disadvantages. So what are the two common types of metal roofs typically used with this aluminum zinc product? Exposed fastened roofs, like your corrugated type panels, and then concealed fastened roofs, usually referred to as standing seam in the business. So, you know, this product is widely available. So not hard to get. That's not a drawback to it at all. Again, form bare or painted. But then the difference really becomes the type of panels that are made out of it and how you use them. So, right, concealed fastened or standing seam often goes by the name of snap lock, snap seam. There's mechanical seamed panels as well, and then batten style panels. And it's exactly what you think it is. There's no exposed fasteners, right? When you look at the roof, you can't see how it's attached. Everything's happening underneath or is covered. And then, of course, there's exposed fasteners. So trapezoidal, box rib, corrugated panels. Right, you get up close to them, you can see that there's a screw, a nail, or a fastener that goes through the panel into the roof deck that you can see from the outside. And then metal tiles and shingles, kind of a subset that falls into either one of these categories. Some tiles and shingles are exposed, fastened, some are not. So we'll start with the concealed fastener. This is what we see most often in big architectural projects, commercial projects, right? So you lay your panel down. There's a flange on one leg, right, where you can affix a screw, a nail, or a clip to hold that in place. The next panel snaps onto it to lock it in place, and onward you go across the roof or the wall. Usually some sealant used, right, to give it some weather tightness and weather protection. And then, right, you just continually covering that fastener with the next panel. If thermal movement is an issue, which it normally is with any kind of metal roof, whether it be aluminum or coated steel, you're going to want to use a clip that allows for that panel to have some thermal movement on the roof. So, right, it's these are great panels. They look great. You can do a lot of design stuff with them. You often see them with some striations or ribs. That helps break up any oil canning, gives the panel a nice look, lays nice and flat. Clip versions, right, again, would be needed for longer span, like big long panels, 20 foot and up. And then if you needed wind uplift performance criteria, you'll have to go to a clip type system and probably a mechanically seamed panel as well to get that performance. So yeah, so speaking of mechanically seamed, right, so your panels snap together, and then you actually take a device that rolls and crimps this edge, this seam together, locking it in place and rolling it over. This is going to give you superior weather tightness. Anything that needs to have a weather tightness or a water penetration warranty is going to have this kind of roof on it. You can also get really good structural performance out of this in high wind areas. It's the most recommended product for low slope applications, but it is more expensive to install. It's more labor intensive. You need an installer who really knows how to work with the product and use these seamers correctly. Some of these types of panels actually are structurally rated, so they can be applied over open framing, right? They don't need a solid substrate or roof deck underneath them. And again, they always use a floating clip system that lets them move around a little bit. So then the other type is batten style or T-style concealed fastener. So again, you attach it with a clip or a fastener of some sort. The panels lock, you can see that, and then you put a cover, right? You put this little batten piece over that so you don't see it in the final product. This gives you a little bit more flexibility in the width of this pan and how wide that panel is. So a little bit more design flexibility. You can do curved, tapered, and conical shapes using this style as well, which is desirable at times. Is more labor intensive, might require quite a bit more gaskets and sealants to get weather tightness. And then the T panel is just a version of this where the connection actually looks like a T and they put the batten over it rather than this spaced out clip arrangement here. You get higher panel profile performance with the T panel. So exposed fasteners get used in a lot of, this is very traditional metal roofing, right? People think about tin roofs or old barn roofs. They're going to be exposed fastener setups. So R panel or U panel, those names get used in the market. Again, most common type of roof panel used for agricultural and economical residential applications. Shaped for maximum strength, but optimizing speed of install. This is a kind of panel that a do-it-yourselfer could do, right? Someone wants to build their own outbuilding or their garage. They could go and buy these panels and put them on themselves, not a high level of installation expertise required. So that's kind of what they look like, right? So you put one down, you put the fastener through the two where the ends meet. You do want to use some mastic or sealant to seal that for weather tightness as well. The 5V crimp, or the crimp panel, it's technically an exposed fastener, but from a distance, it kind of mimics a standing seam concealed fastener panel, right? You got to get really close to see that it's got this exposed fastener on one of these ridges here. So another option if you want the look of standing seam, but don't want to spend the money for it or don't have the installation expertise to do it. Corrugated, right, or sinusoidal, really popular, both of these, and the trapezoid or the box rib. We've seen these are very popular the last few years for wall panels, right? Because you can do a lot of design stuff with them. You can do them horizontal or vertical. You can mix and match that. We've seen some great projects, even big commercial projects done with these that look fantastic. So the curved edges, right, is a little bit softer look, gives you a little bit of a kind of a vintage old world feel, right? Because this is all metal roofing was at one point in time, was corrugated. Blends well with old traditional structures and architectural types. Trapezoid, right? This is a little bit bolder look. You get these big 2 to 3 inch spans of forming. But again, we're seeing them a lot in modern building design and new urban and industrial settings. It's a great look. And again, you can do vertical or horizontal. The rib height is up to like 2 inches on these. So they're really nice for large surfaces that need to be covered. And then metal tile and shingles. These can be either stamped or roll formed, depending on the supplier. They look very much like what they're trying to mimic, especially if you use the right paint system. If you use like a low gloss paint or a print pattern, you can really mimic a real tile or asphalt shingle or slate shingle. But they're often exposed, right? So you're nailing one down and then one clips into place and that fastener is left there. Whoops, my bad. One over the top there. So a lot of different options. Some of these are sometimes also coated with actual, you see stone coated product, it actually has little granulars or stones on the top to really mimic asphalt. These can be a little bit more difficult to shape and install and come at a little bit higher price point. So quick overview, pros and cons, right? They all come to the table with something to offer. The exposed direct fasten is less expensive, it's more economical, easier, faster to install, probably a wider variety of patterns and options. Again, they're pinned at attachment points, so there's really no allowance for thermal movement, which could be problematic, that you actually stretch that hole where that fastener is over time, which could lead to water intrusion and corrosion. Don't recommend it for low slope or for very long lengths because of that. You may need some additional sealant or mastic to get a good weather tightness on it, but you can be curved. It can at times go over open framing, can be installed over existing roofing perhaps that's there, which is a plus. The concealed standing seam roofing, right, it's a step up. It's a cleaner look, larger flat areas, no visible fasteners, superior weather tightness, great for thermal movement because you're using clips that allow it to move. It can be formed on site or in extra long lengths as well. So I've been on projects where they're forming like 100-foot long panels on site and roll forming them and curving them right onto the roof and installing them all at once. So tapered or curved. And then this is what we recommend for lower slope applications. So some things to consider when you're looking at panel designs and trying to figure out what to come up with, right? There's a lot else, as you guys all know, that goes into a building, right? That rib height, what do the shadows look like? What is that at different times of day and from different angles, those viewing angles, how does that look where those seams are, those ribs and forming are? And then the panel width, right? What that coverage is of the final product and how is that going to be to install and work with? And again, the aesthetics of that. Environmental factors, right? Load needs, weather factors, wherever the install is going on. You know, how many clips and what does that spacing look like? All good reputable panel manufacturers will have detailed installation recommendations and guides for clip spacing and clip types that need to be used. What other accessories are going to go on the roof, right? I think, well, certainly here in California, I know that just about every building at this point has some solar panels on it. So you got to figure that in. Are these other attachments going to work with the panel profile? And actually, metal roofing lends itself and works very well with solar panel installation in walkways, catwalks, other things that need to also be installed. Oil canning, it's coated steel and aluminum, you know, has a propensity to have some waviness in the center on long spans. So you might want to consider some striations or little ribs in there to break that up for a better look. Paint system type, we have a whole nother webinar on that, but I know there was a really good question earlier about what does the paint system bring to this. There's three main types out there: polyester, SMP, and PVDF. What you select is going to really depend on what kind of warranty you're looking for and where this building's going and what it's going to be exposed to. And then any manufacturer compliance that's needed, right? Fire ratings, wind uplift, hail impact resistance, right? There's UL and FM Global certifications that most manufacturers can supply and talk to you about on that. Okay, that's the end of that section. Questions?
Thanks, Michelle. I'm going to kind of merge two questions into one here. Both of them are about bending or breaking metal on site. And does one of the kind of questions, does paint add to the memory when bending those? And the other is, how does galvalume compare with galvanized when you're bending or breaking? Does either tend to split on the surface when painted?
Yeah, there is a little difference. The galvalume product does not like really tight tension bends at thicker base metal. That coating will start to open up a little bit, and there are technical bulletins on this. Anyone who's making galvalume will have a host of technical bulletins that cover some of these little caveats and particularities about the product. But yeah, in certain tension bends, the galvalume coating will open up and you'll get red rust bleed through over time. So we do recommend galvanized for that. It's a very small number of panel profiles that fall into that category. For the most part, you're going to see the same kind of formability between the two, between galvanized and galvalume.
Thanks. One other quick question, and this is about using long panels when you have to have an end joint for two long panels. Do you need to allow them to slip without pinning them together, so that allow for expansion and contraction? And if there is slippage, does that create any wear issues with the aluminum zinc finish?
Yeah, you do need to allow for that. I have not ever encountered that there's enough movement that you're then affecting or impacting the performance of the panels. On the long panels and the overlaps, I think we talk about end overlaps here coming up. Really, the big issue there is just making sure you're not getting water penetration between them, right? That leads to corrosion. But as far as wear and tear on the product and the substrate itself, I've not encountered that. If it's occurring, it's mild and minor and not really affecting anything long term.
Thanks, Michelle. We got a couple more, but let's keep going forward.
Okay. Does the slope of the roof matter? So we're going to talk about design aspects. Yes, the slope of the roof matters, and right, we don't want it to be flat. And it matters whether you're using concealed or exposed fasteners and how the ribs are in there and the height of that and the pan length, right, the panel length. So yes, it's important. And again, not just necessarily for aluminum zinc product, but for galvanized product as well. Most of what we cover from here on out is applicable to both types of substrate. So yeah, minimum pitch can really influence life expectancy, right? We don't like to go below 1/4 and 12. So you got to have that or above. Profiles for low pitchers should have a deeper pan, which will allow for more water shedding and help eliminate any pooling that might occur. And concealed fasteners are really the way to go. So you're going to get more effective water drainage, and then you're also not going to have anywhere where water can breach to the underside of that installation. So again, you can go down to 1/4 12. Below that's going to be drainage problems. You're going to have standing water. We have a lovely picture here of what that looks like. So this is a roof that was below 1/4 12 And they've got pooling water that has occurred, and it's not only staining the painted surface, but it's going to start causing corrosion at some point as it eats through that metallic coating. So want to avoid ponding or standing water as much as possible. And again, we'll talk about attachments a little bit more detail here. Walkways, catwalks, solar panels can prevent adequate cleaning and washing. So we want to make sure that that doesn't happen, right? You don't want something that's holding or accumulating dirt, salt, leaves, organic matter, because that's going to be detrimental to the product long term. Most of your warranties and your maintenance guides from manufacturers will have details around this and recommendations. But good design and proper building maintenance, it shouldn't be problematic, right? So yeah, a good enough slope and accessibility that you can, that stuff sheds off, or that you can get in there and wash it down or brush stuff off the surface so you don't get that accumulation. And of course, airflow for solar panels is really kind of needed anyways. You want to make sure you have enough of a gap there between the roof and the panels that nothing's getting stuck and being held behind those panels. Fixture metals should not be used in direct contact. So we're going to talk about galvanic corrosion in the final section a little bit, but you got to be careful about dissimilar metals, especially copper is problematic with coated steel. And that you see copper and runoff from copper sometimes on solar installations and HVAC equipment ends up causing premature corrosion. Vents and fume extractors, we talked a little bit about the temperatures that this product can stand. But in addition to that, it's any fallout, right? Any particular matter that's coming out of a vent or a fume hood or an extractor could be problematic. You want to make sure it's not corrosive. You want to make sure that you've put the vents, you know, such that the prevailing winds are blowing that away if possible, and that it's high enough out that it's clearing the roof as it dissipates and not falling right on it. What we have here is a picture of what not to do, right? So that black that you see running down the panels there, that's actually corrosion of the aluminum component, right? It's oxidizing that aluminum to be black and eating through that metallic coating because of what's coming out of that vent. So dissimilar metals, this is as much chemistry as we're going to do. And like I said, there's not going to be a quiz on it, so you're good. So the use of other metals in direct contact with aluminum zinc can cause galvanic corrosion if conditions are right. So it's an electrochemical effect where one metal corrodes to protect another. This usually happens in moist air or chemical environments like a marine environment or an industrial environment where there's corrosive things in the atmosphere. So the galvanic chart is here on the right. The further apart two items are on here, the more likely this scenario is to happen. You actually create a battery. You can see that galvanized steel and then aluminum, zinc aluminum would fall right down in here. It's quite a ways from copper. It's quite a ways from stainless, quite a ways from titanium. So in a corrosive environment, that distance becomes problematic. And these items at the bottom here will sacrifice themselves to protect items at the top of this list. So want to avoid that. And it does happen in corrosive environments. Only in a benign environment, you really don't have anything to worry about. And again, this affects fastener selection, trim, gutter connections, any clips that you're using. I think I've got an example coming up of a lighting fixture that was in direct contact with some panels that became a problem. Do not use graphite pencils on aluminum zinc. It will leave a black mark that you can't get off. So how do we get around this? Well, the recommendation is that you use the same coil and metal of aluminum zinc for everything that you can, right? You use it for the trim, you use it for the gutters, you use it for flashings, use it for the ridge caps. So you have similar stuff in contact with each other. For painted product, it's okay to use aluminum. Galvanized, we don't really recommend because of the differing in lifespan, right? That the galvanized components are gonna fail before the rest of the roof does. Again, copper and stainless because of galvanic corrosion, not recommended if it can be avoided. And then of course you wanna make sure that you don't have standing water on any of your trim or gutters, right? So make sure you have enough fall and that they're shaped to provide enough clearance at the bottom to get drainage and stuff away from the panels. I have some examples. Again, pictures are worth 1,000 words. So this is a police station in Hawaii. It had painted galvalume panels, this patina green color. It was pre-painted, and then it had copper fascia here and up here. We got a complaint of red rust corrosion on the lower roof only was occurring within a few years of installation. Went out and investigated it, and what we found is that the way the winds blew and the rain patterns here was on Kauai. So the water was blowing off of the top copper fascia onto these panels and running to the edge and sitting, and we had galvanic corrosion occurring, and the galvalume was sacrificing itself for the copper. So that was an odd one. Took us a while to figure out what was going on at first because it wasn't on the same plane where the root cause was up above. So other design considerations, right, is so aluminum, zinc, metallic coated roofs are going to expand and contract the same as any other steel coated product. You don't have to worry about that, right? Obviously, things heat up, you get more expansion. The longer the panel, the more the movement. There was a great question about that. And again, you protect and overcome this through product selection and appropriate clip selection and placement. You know, if it's exposed fasten, attaching directly to wood or steel purlins can relieve some of that thermal movement on smaller panel lengths. But clip selection, right? A simple design is a one-piece clip, the top there, fixed to the substrate, and then a floating connection with the panel. The clip doesn't move. Or you can go to a two-piece setup where the clip is fixed to the panel and base, but has a floating component within the clip. So the clip can move, and the panel can move as well. But you still got a pin in one location to address loads. Environmental considerations, wind uplift, we talked about that. Maybe not as important out here in the West as it is, you know, where there's hurricanes and tornadoes. Air and water filtration rates. Product loads like snow loads, right? Snow adds a lot of load very quickly and then slides down the panels. Want to make sure you've designed for that and that you've got snow stops or snow guards in place to help prevent damage. Ice dam prevention, coastal corrosion, we talked about the protective finishes that go with that and help you get a warranty. And then trim, flashing, and transition details for the conditions present. So this is my one disclaimer. This presentation is not the perspective of an expert in panel design and installation, not my area of expertise. Please don't ask me any really hard questions about installation because I will not be able to answer them. So, and again, all good panel manufacturers are going to have detailed product sheets, installation guidelines, and engineers on staff that can dive into this stuff with you. Okay, questions after that session?
Thanks, Michelle. Now I want to ask you a question about installation, but
Thanks.
So somebody wants to know, all right, so the zinc sacrifices itself and the aluminum doesn't degrade as much. Why not just use aluminum?
That's an excellent question. I mean, aluminum is an excellent product, but it comes with a fairly substantial cost differential and not in a good way versus steel. And it doesn't have the structural integrity. So you have to go to higher gauges, thicker aluminum to get the same structural performance that you get out of steel. So there's some trade-offs there that have to be considered. Cost, and then the structural integrity of what you're doing. But no, aluminum is a very good building product. We actually say that as much as I love our galvalume product and think highly of it, and especially in corrosive environments, so a marine location, probably the best product I could recommend would be a painted aluminum panel. The next best closely behind it would be painted aluminum, zinc, steel, and then galvanized. That would be how they're tiered. But no, it's a good product, but doesn't have the structural integrity and properties of steel in the lighter gauges. And it tends to be most of the time much more costly to purchase.
Thanks. I've got a couple more, but I'm going to ask you to keep going because I got to start it. So.
I'll talk faster than I already do. So what materials can cause premature corrosion? So we're going to talk about, right, where we see issues with this product. Wet cement, soil, dissimilar metals, which we already talked about, and in a corrosive environment. Wet or chemically treated wood can be problematic. and then some other miscellaneous materials that allow for the trapping of moisture up against the surface that leads to corrosion. So again, we're going to talk about fasteners, insulation, sealants, cuts, in cuts, and cuts out in the field, integration with other materials and other roof elements, job site cleaning, and some maintenance practices. Fasteners, very important. Got to use fasteners designed to go with the aluminum zinc panel. Again, there's technical bulletins and lots of data out there on this and recommendations as to what's best. They can include carbon steel 400 or 300 series stainless in a non-corrosive environment. That's very good. In a corrosive environment, you don't want to use stainless. So you always got to check for compatibility. Galvanized is generally okay, but we try to avoid direct contact. So there's a lot of coated fasteners out there that have either a paint or a polymer coating on them, so you're not getting that direct contact. Want to make sure you're using the right rubber washers and spacers, or a fastener that's not exposed to the elements. So what we have here is galvanic corrosion. The top picture was taken in 2008. This had been installed for about 3 years at this point. Came in as a paint failure. My paint is blistering, my paint is bad. That's how the claim came in. Went out there and inspected it, and that fastener and this clip that's holding the gutter in place here is stainless. This house is about 300 feet off the surf break outside of San Diego, so highly corrosive environment. So we went back in 2011. It's just continuing to get worse. This galvanic corrosion will occur until this panel is completely rusted through and gone. So now we're getting red rust, right? There's no metallic coating left. The paint's come off, and we're down to base steel. But you'll see that the stainless looks fantastic still. And that's galvanic corrosion. This is another fastener issue that at first glance looks similar, right? We get blistering of the paint around the fastener. You might go, oh, this is galvanic corrosion, but no, upon further research and investigation, this is actually a fastener that was overdriven into the substrate and then left an opening through that metallic coating where moisture could get in and cause the corrosion process to start. Again, penetrations, avoid incompatible materials. Copper, we've got some pictures here. This is copper runoff from some piping and stuff that's corroding the panel where it drips and sits. Any incompatible material should be post-painted with an appropriate coating system to prevent the migration of copper ions. Roof penetrations need to be sealed with flexible EPDM or a silicone rubber flange sleeve to protect it from water. Use neutral cure sealants. There are technical bulletins on all the sealants that are good to use with this product and approved. Want to install AC units on similar aluminum zinc curves to avoid water dams, or aluminum if it's welded. And then preferably you want to drain condensation all the way to the ground, right? Rather than it running down a roof panel. Edges and terminations. So, most roof or wall materials, they are manufactured to the needed length in the field, but that can't always be done, right? It's part of that process. So sometimes we have to cut in the field. Transportation lengths, right? We can only transport panels that are up to a certain length on trucks as well. So we may need to do some overlapping, inlapping, or cutting in the field. So, right, if you've got an inappropriate roof pitch, which we've talked about, and a lot of condensation or moisture, that can be problematic. These inlaps, you want to use a good sealant. You always want the inlaps, right, to run downhill so water can't go back up between those panels. Make sure you've sealed it good. Double bead and triple bead tape sealants are commonly used at these overlaps and in panel ends and at curves. And you always want to waterproof other joints and transitions as much as possible. Insulation. Fiberglass roll insulation is commonly used with this material, and that's fine. You just want to make sure it can't get wet, because if it's wet and then it's sitting in contact with the panel, you actually have inside out corrosion that occurs. So the corrosion will start on the back side of the panel and work itself out to the exterior over time. Spray on insulation can be used. We've seen that used well, but you got to make sure they don't have a fire retardant chemical that contains copper, which is then corrosive to the aluminum zinc substrate. You want to repair all vapor barrier seams and holes anytime you see them and do regular maintenance. Concrete and mortar, big problem out in the field. So aluminum zinc suffers rapid corrosion in contact with wet cement or concrete. It's during the setting process or when buried in the concrete. You want to make sure there's a barrier between those two things. Mortar splashes can be problematic, right? If the mortar or dropping splashes gets on there, you want to clean it off very, very quickly, or it won't come off, or it'll leave a spot of corrosion. And again, don't use aluminum zinc products submerged in soil. Don't use it for culverts or potting plants or signage that's going to go in the ground, anything like that. Here's some examples of woods. This is a tree. Green or unseasoned timber shouldn't be used because of the moisture in it. And you want to use kiln dried timber as much as possible. And then we've also found, again, a lot of fireproofing, fire retardant material has copper in it, which is problematic because of the galvanic corrosion. Storage and handling on site is really important to metallic coated products. So while this product has a superior corrosion performance once it's installed, it can be problematic when it's stored. If it's stored and stacked in the bundles and moisture gets between there without any airflow, it accelerates the corrosion process. You get storage corrosion. So there's a lot of good information on how to store this at job sites so it doesn't get wet before it's installed. And then handling it, especially on long lengths, you want to make sure that it's getting handled or lifted up to the roof so you don't kink it or bend a panel or dent a panel, which can then not only looks unsightly, but can hold moisture and water and have other issues long term. Field cutting. Yes, field cuts happen. They need to happen. Valleys, terminations, etc. They should be protected and hidden with trim as much as possible, if that's possible. The burr done during the shearing and cutting action should be down, which allows water to drip off that edge and not hold onto it. And then you can even slightly bend or downturn cut ends or eaves as well to prevent water pooling and by capillary action holding on that cut edge. In severe marine industrial environments, we do actually recommend that field cuts, if they're going to be exposed, be painted with a field paint or some kind of sealant to give them a little bit extra protection. Site cleanup, this is a big one, right? Brickwork, it usually requires 1 part hydrochloric acid to 20 parts water to clean. If you leave that in contact with the metal panels too long, it can lead to corrosion. So you want to mask off well or clean well right after. Swarf is huge. These are metal filings left either from fasteners being drilled in or cutting that's happened on site. Little metallic filings sit on the surface and then they rust and it leaves this unsightly red stain on the panel. And the complaint comes in as my panel is already failing and it's brand new. And you go, no, that's something that got on the surface that didn't get cleaned off. Once that stain sets in, it's kind of there for life, unfortunately. Want to make sure no cables or electrical conduit or other materials remain on the surface long term that could catch or hold moisture or debris. And then if these painted roofs do require touch-up, just keep in mind that the air dry touch-up pins you're going to get are going to fade a little bit different than the factory applied paint. So you want to minimize their usage as much as possible. Maintenance, got to do maintenance, right? We got to do maintenance on everything. As much as we don't want to. Frequent cleaning, at least annual cleaning and washing, get debris and dirt off the surface. Makes it look better too. It's like cleaning your car. Most warranties are going to have some language around how frequently to do maintenance and what that should look like. The industry standard is just a 1/3 cup of Tide or Tide-like detergent, and then wash it down. It's pretty robust. Spray it. Try to avoid buildup. If you got a lot of leaves collecting or pine needles or something, you got to get those off of there. They're really detrimental, especially to a painted surface. Right? And if a roof leaks, don't seal it. Find where it's coming from, fix it. Okay, we're at the end. We're at the summer. I know we're a little over because we got a little bit of a late start. Questions?
Thanks, Michelle. Yeah, a couple of questions and a clarification about galvanized and galvalume. Are they compatible, or if they're in touch with each other, is there a galvanic corrosion problem there?
There can be. Oh, I don't have my cheat sheet in front of me. In benign environments, not too bad. There is I wish I had my technical bulletins in front of me. There's a technical bulletin on it, and I think it's, oh, don't quote me. I should know this. if water is running from one to the other, it's okay, but the reverse is problematic, and I always get it backwards. I would have to look at my technical bulletin.
I'll encourage this person. We have your email in the follow-up.
Yes, I can get it for you.
And the other question is, again, about galvanic corrosion, but this time copper gutters with a Kynar, a PVDF painted metal roofing, should they not be near each other?
Yeah, they really shouldn't. Yeah, it could be problematic, depending on exactly how the water is flowing and that connection is made. Yeah. Again, there's a whole technical bulletin that gets into the details of this galvanic corrosion by specific material and what can and can't happen, or should and shouldn't happen, I should say.
You talked a little bit about dealing with filled cuts and applying those treatments or paints to those ends. This person is asking specifically about a raised rib. Is that any different than just kind of like a panel, or treat them the same way, or?
So what I'm not sure I understand. So it's a raised rib on the panel profile?
How to treat the end of a raised rib.
Oh, if it's exposed, yeah, you can do the same. You could use like a clear sealant. Yeah. The problem with those edge sealants and edge paints that we've seen though is people get sloppy about putting them on, right? And then you get bleed over onto the panel itself, and then it starts to weather differently than the rest of the panel. So, you know, I'm kind of torn. You know, unless it's really a severe environment, I say leave those edges alone. Let the metallic coating do what it's supposed to do, which is provide some protection there on that edge long term.
Great.
You know, the other thing with field applied coatings is they do wear off. You kind of need to reapply them on a regular basis, which most people are probably not going to do. Yeah.
Michelle, thank you so much for a great webinar. You're always such a great resource of information, and I'm sure people will want to follow up with you, as I said in the email coming out tomorrow.
Absolutely.
The email will be there, and they can touch base with you. Also, there will be a link. A couple of people asked, there will be a link to be able to download this presentation, so there'll be a copy available then. If anybody else wants some more information, you go to steelscape.com. A reminder that the AIA credits and the certificates are going to be handled automatically. Just give us 5 days for all that to process. Again, tomorrow you'll get an email about more of that, with more of that information. Our next webinar is going to be August 25th. We're taking off July, I guess going on holiday. It's going to be on metal roof systems design and installation considerations, and it's presented by AEP Span. Thank you all for taking time from your day to join us. And Michelle, thank you so much for a great presentation. Always appreciate it. And everybody
Thank you.
Bye.
Bye.